It's not easy for us busy geotechnical engineers to keep up with industry trends while keeping up with our engineering work. Therefore, it's our goal at the Geotechnical Engineering Podcast to help you do just that. We strive to keep our listeners informed on important industry topics and also to educate you on interesting technical topics and trends in the geotechnical world. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Keithe Merl, who's the Northeast Area Manager at Hobas Pipe USA. We'll be talking about different aspects of geotechnical engineering, why geotechnical education is important, and what the future holds for geotechnical engineering. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast.
Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Welcome to the show, Keithe. How are you doing?
I'm doing fantastic.
Good to see you again. Good to see you again. I'm glad that you were able to come on. And I think just to set the stage, if you could tell our listeners a little bit more about yourself and what is it that Keithe does on a daily basis?
Yeah, it's always I ask myself that question all the time. What do I do?
Yeah.
But yeah, so I'm a graduate from Drexel University back in 2001, and then shortly thereafter, I was able to get my PE. Now I went to Drexel for 7 years, which normally means you get a bigger degree than a BS. But I had to work full time while I was going, so I did it the hard way to get there. But did a lot of master's coursework, but didn't quite make it to the master's degree. There's a point where you just gotta get moving, and for me, it was all about being in the field. And when I started at Drexel, it was architectural engineering. I like to draw buildings and things, but once I really got into the nuts and bolts of that, it was the stuff under the ground that really got me interested. Starting dealing with soils and those sorts of things and geologic hazards, and that's really what my coursework at Drexel was. So I sort of went the whole gamut, buildings all the way down to the ground. And if you think about it, what we do as geotechnical engineers involves all that. It's the stuff above the ground, it's the stuff in the ground, and all those sorts of things. And there's a lot of things that I would tell newer engineers as they come up is, you don't really know anything as a geotechnical engineer.
Yeah.
So structural engineer, what do? You say, well, I need 50 KSI steel. And what do you get delivered? You get 50 KSI steel, right? Everybody knows what's going to happen.
Yeah.
We get out there and we have our crystal ball when we get started, and we say, hey, we think our crystal ball is telling us this. And then invariably, when you get out there, it's not what you thought it was.
Yeah. Yeah, I heard somebody say you're putting together a puzzle with just a few of the middle pieces. It's just like,
that's it. It's so true. So
oh,
true.
man. That's cool. When you were at Drexel, you did the co-op program as well, or?
Yes, that was an exciting series of events. Now, unfortunately, my first one kind of didn't go the way I wanted it to, but the good news is you get a chance to retry. So the ones after that went much better.
Okay. Got it. And what are you doing now? You're at Hobas. What are you doing now? Like, what's your day-to-day look like?
Right. So a lot of people ask me, pipe, how did you go from engineering dams and buildings and ground improvement to pipe? Well, Hobas Pipe is one of the things I really like about it is it's all U.S. based. So everything's made here in the United States. We source almost all of our materials here in the U.S. to the extent that can happen. And everything's built here. And unlike most other sort of pipe places that you might get involved with, we make all the pipe. So there's really engineering involved with that. And then to add to that, there's regular pipe, you bury it in the ground and you move on with life. But we also do a lot of micro tunneling, which is the projects that really get me sort of excited to get up and look at jobs. And if you think about it, the way, even particularly up in our area, so you think about New York City, Philadelphia, Boston, Rhode Island, we're in the megalopolis of the Northeast. And for me, I kind of stop at PA, but I mean, it extends down into Baltimore and DC, and it just keeps going. If you've ever been involved in a project where they're doing road work and you have to get on the other side of the road work, most people don't want to do that. And so trenchless is sort of what they call it in the industry, is really picking up steam here, not only in the conventional stuff we think of. So a lot of people have heard of like horizontal or directional drilling, pretty common in things like electrical, gas lines, that kind of stuff, small diameter. But now we're even talking things like storm pipes and sewers are becoming more and more common. And then I know we talk a lot about climate change, resiliency. That's another reason I was looking at these guys. So the pipe that we make, it's a fiber mortar pipe, fiberglass reinforced mortar pipe. So it's got a bunch of, I think there's more acronyms for this pipe than anything else in the world. Like FRP, RPM, CCF RPM. There's just so many of them. Okay. But the real goal here is that it doesn't degrade over time. So if you think of things like concrete pipe, steel pipe, all the stuff that we've normally seen, that stuff can just degrade and rot over time. And then you also have other forms of it. So there's other polymers like HDPE, PVC. Those things are used not only in pipe, but a lot of those resins you'll see in things like geotechnical fabrics, things like that. So that stuff doesn't degrade, but that's a thermoplastic, whereas we have a thermosetting resin in it. So it really makes a durable long-term pipe. We guarantee the pipe for 150 years. So for me, looking to the future for my kids and their kids, that's another reason I kind of got involved with this. If we can make everything last a little bit longer. If you think about water supply, wastewater treatment, stormwater control, and if you go out to the West and the Midwest, you're talking about drought and moving water around. And, one of the things that I think we get so used to here in the Northeast is all of our water and stormwater regulations are written to say, hey, don't put your extra water on my property. Don't flood me out. You go just out into Ohio, and they're saying, if you don't let me get that water, we got problems.
Wow, look at that.
So we're used to our regulations saying stop the water. But as you go in other areas, they really want it. And so for us, it's all about trying to work with what we got too. Kind of going back to where I started from. If you've ever driven on the Garden State Parkway, which I'm sure you have, that's 14 lanes at some point on 4 embankments. How are you going to trench a pipe across that? The safety is out of control. Traffic would be crazy. All of those things would add up. And so if you can reuse the existing pipes in place, or you can burrow a pipe under it, there's a lot of value there, I think, across the board. And a lot of the DOTs are starting to see that, particularly if you can reuse old pipes. If you think about New Jersey, particularly, just because it's easy to talk about, if you go up and down the coast, they have a lot of sand. You have ocean water up and down the coast. So all these things tend to corrodable materials, concrete, steel. And so this stuff was put in 30, 50, maybe 70 years ago. And it's really at the end of its life. And if you can reuse the hole you already have and fill it back in, all the better. And that's one of the things I'm working a lot on, to reuse what we've already got.
Oh, that's great. No, the reality is that, infrastructure is something that's been, something that we've been talking about for a long time. And, infrastructure has age to it. And we're at the point where we need to figure out how to refurbish or how to provide new life to infrastructure. So if you're saying you can reuse the existing and slip line it or work within it, I think that makes a lot of sense. So pretty cool. And you spent your whole career, I understand, in life in kind of like the Philadelphia area. but still you worked on projects that are, all different types of varieties from the shore to Maine and into Canada. Think about one project that was special for you, and maybe you learned something that you still carried with you today. What can you share with our listeners?
Yeah, it's the array of projects. For me, it was dams. When you're doing work on dams, that's that type of work and learning from that. If you think about how a dam works, you have not only soil but water and all these other things around it. And from a geotechnical standpoint, it's complicated because you have this water that's constantly bombarding what you're working on. So when we talk about soil, right? What do we think? We think the kind of dirt you pile up in the yard, right? It kind of looks dry, feels dry. When we talk about dams, especially earthen dams, it's all soaked, and so the soil works differently. So I had done work on several embankment dams in Pennsylvania where we had to assess it, make sure it was still stable. So doing geotechnical work on and through those structures, learned a lot. You're not going to do sort of what I'll call the standard or run-of-the-mill testing. You're going to do advanced testing, and you really get a feel or a sense for how soils respond to sort of the worst condition it could be in, which is totally saturated, generally speaking. But yeah, there was a handful of those up in the Pocono area. So a lot of big hills, kind of deep embankments, that sort of thing.
Okay. Got it. Were you on the design side for those, the construction side, or?
Well, with dams, it kind of ends up being both. So you do as much as you can out in the field. And these are like old farm dams that some guy just bulldozed the dirt in and he was using it to water his crops. And then somebody said, hey, we really want to build a community around this lake. And so now it becomes this community dam with people around it, and you don't want people getting hurt. Yeah. So anyway, there's usually not a lot of data, at least on those, unlike FERC regulated dams, that sort of thing. So you're going in blind, as my mother always told me, you get what you get and you don't get upset, but you figure it out. So obviously working with earthen dams, that's one of the pretty far extreme conditions that you're going to work with as a geotechnical engineer, and just learned a whole lot from doing the engineering for those types of structures. And then that really tied into learning a lot more hydraulics. Certainly you take a little bit of that in class, but understanding the hydraulics around a dam in total. So how much water is going to be upstream, how much water is downstream, and how the water goes through the structure. A lot of us think of dams maybe as an outlet pipe or something, but there's also the overflow channels on the sides, and those have very interesting hydraulics. So I pretty much learned when you think about engineering, geotechnical in general, water, soils, jumped right into it. And being in the Philadelphia area pretty much my entire career, is one of the things I always told junior engineers when I had them on my staff is, welcome to Pennsylvania. You have basically every geologic issue except for active volcanoes.
Yeah.
So, if you think about anything you would do around the area, whether it's in Philadelphia, which generally has good basement rock like you generally have in New York City, but you have a whole bunch of historic fill over it. And then all the way out to sinkholes, out in the edges of the Philadelphia area. This is essentially the only place in the U.S. where you have terminal moraines from glacial advances from both of those advances still in place.
Yeah.
In most cases, the secondary advance would push out all of the initial terminal moraines, and those are interesting because that's where typically you get large erratics, things like that, boulders the size of a small car, that when you're drilling or trying to figure out how you're going to support this building, it's kind of tough to work around big boulders sometimes.
Yeah. Yeah. If you're going to drill, you have a known obstruction that's unknown. Like, where is it? Right.
And you're either going to miss every single one of them or find them all.
Exactly.
I don't think I've ever had a job where it's in between.
Exactly. All right, great. Well, you alluded to, like things you would share with staff. We have a number of younger listeners that call in, and some of them call in that listen in and watch. Some of them aren't too familiar with what geotechnical engineering is. What would you say, how would you briefly explain some of the different aspects of what geotechs do?
Geotechnical engineers, they are really the gum that sticks all the other engineering together. So any other structure or anything you really deal with, it's going to land on the ground at some point, really. So bridges, buildings, water structures, hydraulic structures, dams, almost anything that you make in this world is going to be interacting with the soil in some way. I mean, even think of pipes. You're going to bury a pipe. What's it? It's completely buried in the soil. And so we, as geotechnical engineers, not only need to know our craft from soils, but we need to know almost everyone else's craft enough to ask the right questions. When it comes to things like structural engineers, I've always had jokes with the guys I know really well, and they would say, "Okay, just tell me the bearing capacity of the soil." And I'm like, "Well, it depends." And they said, "Well, can't you just give me one number?" It's like, can you give me one column load for every column? No. So it becomes that discussion, and we I know in school, at least for me, back, I was back in the late 90s. I feel like we were always kind of taught to have the answers before we ask the questions. And as a geotechnical engineer, I think you have to ask more questions than maybe some other engineers. And if I had one piece of advice to any engineer looking to do what we do is just listen. You have to be a good listener, because and I run into this problem, I think, like every engineer, right? You kind of get the blinders on and you're doing your design, and you're getting to that end goal. Your end goal is, you're trying to get there, and sometimes you just get tunnel vision, pun intended, and you're trying to get there and you just stop seeing all the periphery. And so sometimes you got to stop and just listen and ask questions and say, okay, when it comes to this building that they're trying to construct, what can it actually handle? What can it handle? What's it going to be made out of? How heavy is it? And then dams is kind of the whole other side. How much water do I expect to get there? How quickly is it going to get there? What does that mean the dam has to be able to do? How does it change what I look at? Pipes, it's really the same thing when you're looking at pipes. What soil is it going in? And we tend to forget that pipe networks are structures as well. And in fact, if you probably talk to anybody in the water, wastewater, stormwater, engineering sector, they're going to tell you that if the wastewater treatment plant or the well house pump is the heart of the operation, the piping is all the veins and the arteries. So you could have the best wastewater treatment plant in the world, but if you can't get the waste to it, it's not treating anything. And so those are the structures. They're truly our structures. It's one of the things I do a lot with civil engineers now is just talk about the idea that a pipe is a structure. So let's not just say, just throw it in the ground and get on with life. Let's make sure that we understand the pipe that's going in the ground. Is it flexible? Is it not flexible? How's it going to respond? We don't deal with it a whole lot up this way, but seismic reaction, it's not that we don't have earthquakes, we just have small ones. So how does it respond to earth movements, sinkholes, water tightness, all these things. Soil conditions up here are kind of horrendous. I mean, they're pretty tough. A lot of people think of, okay, what goes through the pipe, that's a problem. Is it, an acid is, but around here, it's like, what's around the pipe? That's a problem.
What's going to be there for all that time? The pipe sitting in it. Okay.
A lot of people don't even realize in New Jersey, particularly, but also in this side of Pennsylvania, we have a thing called acid producing soils. I don't know if you've ever run into those. They are the way they react when exposed to air is the water that's trapped in them, actually the pH drops as soon as it starts to oxidize. And so if you dig through these and try to throw, say, a piece of steel or concrete pipe in and you don't realize you run through them, it'll start corroding the pipe immediately. Like the pH in the soils can be as low as like 3 or 2.
Oh my goodness. Thanks.
And where do all of our pipe networks go? Through the worst sites, because nobody wants them in their front yard, And that's where all that stuff tends to be.
Wow. Well, good stuff. Good stuff. Lots to consider there. Lots to consider. Um, what would you say when you think about, your education in engineering? How would you say that shaped your career and where you are today? And I like the way you said it before. You said that you did your undergrad while you were working. So it's like, your work may have influenced your education influenced your work. But what are your thoughts there, Keith?
Uh, exactly what you said.
Hmm.
I was able to take exactly what I learned in the classroom, take it into the field, and then I learned some things in the field that I could take to the classroom.
Hmm.
So although it's a lot of work to do, it's certainly worth it if you can get in as an engineer, particularly in soils. I think
Mhm.
it's applicable to others, but I think soils it's really good to get out there, touch, feel, smell. A lot of the things that I learned or became more muscle memory was when I was in the field and I could see those soils, see those conditions in real world, real
Mhm.
life. So when I was on some of my co-ops, I would actually do sinkhole repairs,
Hmm.
and to see a live sinkhole throat, be able to chase that throat, do all the repair, and there's a couple ways to do it depending on the conditions. And working with the engineers that had the experience, you really get a good look at what you're getting into. And then as part of that, I would always tell a geotechnical engineer who might be leaning more towards the design of foundations and those sorts of things to take courses in the actual geomorphology of the soils themselves.
Hmm.
One thing that I learned a lot in school, so my professor for the master's courses I took, he was a geologic hazard kind of guy, and so for him it was looking at nature as well.
Mhm.
So there's a lot of things I can do as a geotechnical engineer without even drilling a hole to understand a site just from the nature of the site itself. Now, whether that's elevation or grading, but you can even look at the vegetation.
Mhm.
So look at the size and types of trees. You can look at some of the different weeds. So easy, for instance, there's a Japanese knotweed. I mean, that means there is disturbance there
Hmm.
typically. And so you can right away know, hey, somebody disturbed here. If you see a big change in the caliper of the trees, you know that maybe a large part of the site had been cleared at one time.
Hmm.
And so there's all these little bits and pieces, and then soil morphology is important. So natural soils have a fabric to it. And obviously it changes depending on where you are.
Mhm.
But as soon as you disturb it, the fabric's gone. There's no way to remake it. And so when you're out looking at soils and boring and the borings themselves, even though you are disturbing it most of the time,
Mhm.
knowing what you would expect to see, and I know a lot of engineers just totally say, that USDA soil stuff isn't useful to me, but it really truly is, I think, useful to all of us to at least understand. So there's some basic soil morphology in there that if we know what that is going in,
Mhm.
we can right away tell if we've run into something that shouldn't be there or we wouldn't have expected to be there. So the melding or the meshing of those two is very important in my mind. And what I found was when I went into the geologic hazard stuff, they really tied in being out in the field and doing it in person, very directly, and I got a lot out of that. That was super important to me.
That's great. A lot of clues that are there before you drill that first boring or excavate that first test pit. So really good, really good. What do you think the future holds when you look at geotechnical and civil engineering as professions? Like, what does the future look like for us?
I think we're gonna be the key to dealing with the issues we're seeing nowadays.
Hmm.
A lot of discussion about flooding. If you think about the wildfires, geologic hazards, landslides. I was just reading in one of the latest periodicals, Geostrata, about how the storm intensities are happening more frequently, and so a 30-year design for a pipeline, let's say, has almost a 30% chance of failing in those 30 years
Hmm.
completely.
Wow.
And as civil engineers and geotechnical engineers, particularly, I think, because they all sort of fall under the same, I think it's really on us to help educate everybody else. Like, listen, this is not just a could be a problem. It really is a problem, and we need to start thinking ahead for it. So, people talk about 100-year design, 100-year storm, and the terminology there is a little bit misleading. It's not that the storm would only happen once in 100 years. It's a percentage of a chance of it happening in the year, or even at that particular storm event. And the other thing I think that really changes and has been changing what we do is the amount of data that we can now collect and be privy to. I definitely think things are becoming more intense, but I also think we're hearing more about it because there's this big sharing of data and information. And so I think we all need to, as engineers, I certainly believe it's in our ethical requirements to try to think ahead. So in terms of the infrastructure of our world, having the same quality of life that we have now, civil engineering is going to be the industry to be in. And it can be any aspect of it. I mean, if you think about it, we civil engineers, we touch pretty much every type of engineering. And some people might say, well, you don't really touch process engineering. Yeah, we do. You got to hold those processes up somehow, right? So.
Yeah. It all ties back. I love it. Love it. All right. Well, before we take our break, final piece of advice. You've given a lot of advice, but final piece of advice for some of the younger listeners.
The final piece of advice for any young engineer, and I mentioned it before, but I think I need to say it again, is just you have to be able to listen. Don't jump into, say, an answer without listening first. And I felt like for me in school, I had a tendency to do that a little bit, learn how to undo that later on. So listen, it's okay if you pause, think about it. Always want to think about what you're doing or what you're saying, and don't be afraid to ask questions back. So it's not going to make you sound like that you're not capable. It's going to make you understand better how to solve someone's problem. And that's what I think engineering is. We're trying to solve problems.
Yeah.
And so listen, don't be afraid to ask questions, and then let's solve problems together.
All right. Sounds good. That's a good note to pause on. We're going to come back in just a minute and close this one out with Keith and our career factor safety in segment. Stick around. All right. It's time for our career factor safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor safety into your design. But what about incorporating a factor safety into your career? Today, of course, we're talking with Keithe Merl, the Northeast Area Manager for Hobas Pipe USA. Keith, you've already had a very successful career, and you're still in your successful career. You're not done. But when you look back in your career, not yet, right? When you look back in your career, what's one thing you've implemented to give yourself a career factor safety?
It's always to say yes to something.
Okay.
Don't be a naysayer. Don't be no, right? There's got to be an answer for it. So for me, I have done all sorts of different geotechnical engineering, and I don't view engineering specifically, particularly in civil engineering, as one thing. It's all these things added together. And so always have a mindset that you can do it. It's a yes, figure it out. Don't be afraid to ask the questions, involve and get engaged with other people. If you don't have expertise in it, bring those expertises in and learn from them. And to that point, know kind of when you're just way out of your realm and just say, listen, I need help with this, or I want to learn about this. So I have changed. People would say I've changed what I've done a lot over the years. I ran an office in New Jersey doing, water resources, geotechnical engineering. I then did ground improvement with a design build contractor for a while. Now I'm doing pipe, but it's all the same thing. It's all in the ground. It's all dirt. And so it's just a different version of it. And for me, it's those aspects. I like to learn stuff constantly. When I was the geotechnical engineer, sort of doing what I would call run-of-the-mill geotechnics, super interested in that. I got really involved actually a lot, and this was a yes factor with New Jersey and their work to work on stormwater infiltration. A lot of people think South Jersey, sand everywhere, right? Just disappears. at the time, it was something like a 70% failure rate.
Wow.
And so we're like, well, why is that? And so I was working with everybody as a team to figure out why it wasn't working. And, the answers can be fairly simple and we should know them, but maybe we don't. And then go to ground improvement, right? So the next step for me was I want to get into really complicated soils. And I kind of want to be the person that people are going to call to say, hey, I got these borings and they're pretty funky. You have any idea what we could do with this?
Yeah.
And that was kind of ground improvement. And, having the ability to also say no to things helps. And then the next step for me was I got very interested in microtunneling. And I also have a thing now, I guess maybe I'm older, I have 2 kids, whatever it is. I also want to get more into leaving stuff for my children and their children that'll help them in the future. So another reason why I kind of made this last pivot where I'm at now, and who knows to say what's next. And for me, it's always a yes. Hey, you interested in this? Yeah, I'm interested. Let's talk about it.
Yeah. I love it. Well, Keith, thank you so much for coming on and for sharing such great insights with us. We've gained some great information and advice that's going to be helpful for our listeners. There's somebody that's watching or listening and they want to reach out to you. What is the best way for them to get you? An email you want to share, or social media they can follow?
You can certainly follow me on LinkedIn.
Okay.
I'm fairly involved there. My email address as Keith the Engineer is keithe.merl@gmail.com. And I'm always happy to answer questions, talk to people. It's just fun working with other engineers on all sorts of crazy different stuff.
Excellent. Well, thank you so much. This is great. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 54, as well as links to the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.